In this video, I will give a brief introduction to proportions and discuss how we can calculate probabilities with sample proportions. When dealing with proportions, our response variable is going to be categorical. So this is different from the variables that we've been dealing with most of the time this semester, which have been quantitative. Data from categorical variables is often given summarized as counts. So for example, if I said in a recent survey of 135 statistics students, 87 said that they prefer milk chocolate over dark chocolate. Sometimes when the data is given summarized as counts, it can be a little bit confusing to students because the counts are numbers. And most of the time we talked about quantitative data being numbers, not categorical data. It can be helpful to look back at the individual that we collected the data on. So in this case, an individual would be one statistics student. And we asked that student, do you prefer milk chocolate or dark chocolate? When you look at it this way, it's clear to see that this is a categorical type variable. When dealing with proportions, we're going to be looking at the sample proportion, which we call p hat. Pretty much any time in statistics when we put a little hat on something, it just stands for the estimated value for whatever's wearing the hat. We calculate that sample proportion, p hat, by taking x, the number of successes in the sample, divided by n, the total sample size. So in this case, we would have 87 divided by 135, which is equal to 0.6444, or 64.44%. There's a couple of different graphs that we can use for categorical data. The first one is a pie chart. We use a pie chart when we want to represent the observations as a part of a whole. So for example, here's another question that I asked some statistics students. I asked them, if you could only have one of the following, which would you choose? A DeLorean time machine, a Star Wars lightsaber, or a Harry Potter invisibility cloak? And you can see what the results were here. Now a pie chart can only be used if all of the pieces add up to the whole. So in this case, for example, students were only allowed to choose one answer here. So that means that this pie chart represents 100% of everybody, and you can see what everybody's one answer that they chose was. Another graph that can be used for categorical data is a bar chart, and this is my personal preference. For several reasons. First of all, because a bar chart can be used for any and all categorical data. So even if not all of the pieces add up to 100%, you can still use a bar chart. Also, I think that bar charts are way easier to read than pie charts. So for this data, for example, if you compare the bar chart and the pie chart, you'll notice that there was a pretty tight race between the Harry Potter invisibility cloak and the DeLorean time machine. And looking at the bar chart, you can see that even though they were close, you can tell that the DeLorean time machine slightly beat out the Harry Potter invisibility cloak. Now if you look at the pie chart, if these summary statistics weren't there, there would really be no way of telling whether the blue or the yellow took up a bigger portion of the pie. It's too hard to tell the relative size next to each other in a pie chart. So you have to go back and look at the actual numbers. And if you have to look back at the data, that kind of defeats the purpose of having a graph. So in general, I avoid pie charts at all costs. But it's important to know about them because they do show up often in real life. There's a lot of like financial institutions and things that are really in love with pie charts, so they do send those out frequently. When dealing with sample proportions, we're going to look at the sampling distribution for p hat. So the sampling distribution is the distribution of values taken by p hat in all possible samples from that population. So it basically says, okay, if I were to take lots and lots of samples from this population, from each of those samples calculate a value for p hat, and then I look at the distribution of all those possible p hats that could come from this population for a given sample size, what would that look like? Well, if I took the mean of all those possible p hats, I would get p, the population proportion. Now just recall that the population proportion would be the value for the proportion if we were able to measure every single person in the population. So p is usually what we're trying to estimate because it's unreasonable to actually measure everybody in the population most of the time. The standard deviation for p hat, or that sampling distribution for p hat, is going to be equal to square root of p times 1 minus p divided by n. And the shape of our sampling distribution for p hat is going to be approximately normal, assuming that it meets both of the following criteria. We have to have n times p greater than or equal to 10, and n times 1 minus p also has to be greater than or equal to 10. So using this information, we can go ahead and answer probability questions about sample proportions using a z-score and the normal probability applet. So our z-score is calculated in our standard way, where we have an estimate. In this case, our estimate is p hat, minus the population value, which in this case is going to be p, or the mean of p hat, divided by the standard deviation of p hat, which is here in the denominator. So let's look at an example. 73% of all Pinterest users are female. Suppose you take a random sample of 150 Pinterest users. What are the mean and standard deviation for the sampling distribution of p hat? So starting with the mean of p hat, the mean of p hat is going to be equal to p, or in this case, 73%, or 0.73. The standard deviation of p hat is equal to square root of p times 1 minus p over n. So as we stated before, given to us in the problem here, p is 0.73. So if we plug that into our formula here, we get a standard deviation of p hat equal to 0.0362. So let's look at an example. What's the probability of taking a sample of size n equals 150 and getting a sample proportion p hat greater than 80? So we're looking at greater than 80. So first thing we're going to do is calculate our z-score. So if we plug the numbers into the z-score, so the sample proportion we're interested in is that 80%, so that goes in for p hat. This 0.73 was the value for p that was given to us in the problem on the previous page, and then the 150 is our sample size that was also given to us. So if we plug all those numbers in, we end up with z equal to 1.931. Now it's important to point out here that when we're dealing with calculations involving proportions, we always have to convert those proportions to decimals. So all calculations involving proportions should be in decimal form, not in percent form. All right, so back to our problem. We're going to take that 1.931 and plug that into our normal probability applet, which I did write down here. I'm going to shade just the upper right tail because we wanted to know greater than 80%, and the resulting area is going to be my answer. So my conclusion, the probability of taking a sample of 150 Pinterest users and getting a sample proportion of 80% or more females would be 0.0267, or 2.67%. Now, of course, before we can say that this conclusion is valid, we need to check our conditions. So is a sample size of 150 large enough to meet the conditions for p hat to be considered normally distributed? So for that to be the case, remember we had to have n times p greater than or equal to 10. So in this case, I'd take 150 times 0.73, which equals 109.5, definitely bigger than 10, so we meet that portion. Also, we have to have n times 1 minus p greater than or equal to 10. So both of these conditions have to be met in order for the sampling distribution to be normally distributed. So again, in this case, we end up with 150 times 1 minus 0.73, which is going to give us 40.5, also larger than 10. So yes, the conditions are met and our conclusions are valid.